Question number 7C says 800 students are willing to buy tickets for dance for $10 each, and for every 25-cent increase, there are 10 less students that will buy tickets. So determine the price to charge the maximum to get the maximum revenue. So first of all, we need to recognize what we're maximizing. We're going to maximize revenue. So we need an equation for revenue, and that's going to be price times the number of tickets. Okay, so we need to make this a function of x. So I'm going to start with a price of $10, and x is going to represent the increments of 25 cents, so that's how much I'm going up by, and also the decreases of 10 students. So I'm going to do in groups of x. I'm going to do it like this. So $10 plus 25 cents for every x. And for the number of tickets, it's going to be 800 tickets minus groups of 10. So as we increase by 25 cents, I'm going to decrease by 10 students. Okay, so there's my equation. My price times the number of tickets sold. I now have my quadratic equation. So for the previous one, I solved by completing the square. But this one really, if we have a graphing tool, once we have the equation, we can just graph and solve. So in graphing this, I can get a graph that looks like this. It's a parabola. Now to work out the window, I have to just kind of estimate my x's. So I'm probably not going to go have x be less than, let's say, negative 10. Okay, so negative 10 or negative, I'm going to make this maybe negative 20, and that means I'm going to decrease the price. Okay, we don't really want to decrease the price. We're probably going to increase the price. And x, maybe I'm going to make this maximum of 40, so we double the price. Okay, we could double the price and see what that looks like. And we may have to adjust the window. So for my min and max, I'm going to have negative 20 and positive 40 for my min and max. And for my maximum y value, well, we're probably talking about $10 in price, 800 tickets, so that's about 8,000. We're probably thinking that the max is going to be bigger than 8,000, so I'm going to go to 10,000 and see what that happens. And again, I may have to adjust my window, but when I graph that equation, based on that, I get a parabola that looks kind of like this. And solving for the maximum, that maximum happens at x is 20 and the revenue is $9,000. Okay, so there's my max. So if x is 20, then my price, I have to solve for my price. So I'm going to do it like this. Here's my price. The price is equal to 10 plus 25 cents times x. X happens to be 20. So my price that will maximize my revenue is $15. Okay, the number of tickets, so tickets is equal to, I'll do this in a different color. The tickets is equal to that expression there. So to calculate my tickets, I will do 800 minus 10 times x, which is 20. So the number of tickets sold works out to be 800 minus 10 times 20, which is 200, so I get 600 tickets sold at $15 a piece, and that gives me my maximum revenue of $9,000. So to set this up, we have our, first of all, our equation. Then I need to write my expression for price in terms of some quantity x, and the x's, we'll use x times 0.25 to indicate the increases of 25 cents. And then we have to have an expression for tickets, so 800 minus 10x, so that we're going to go by down, so minus groups of 10, so that's why I get 10x here.